This call is now being transcribed.
Okay. So I know it can hear me because I see it moving in the upper right. So let's look at the review that we have for today. Hopefully all this makes sense. It says determine the quadrant in which the terminal side of the angle lies. I think you can figure those out. Let's just walk through a couple things. So what it's telling us in the first few questions is you have to know that that's quadrant 1, that's quadrant 2, that's quadrant 3, and that's quadrant 4. You know that, yes? Excuse me. And then it says coterminal. So it talks about coterminal. Someone remind me, because you did your homework, wink, what do you do to find coterminal? Oh, not quite. Nope, but you're thinking. Good. We're going to use that in a minute. That's good. That is to convert. We're going to do that in just a second. Coterminal. Yes, what do you think? Very good. So if we're talking about degrees, we take our angle plus 360 or our angle minus 360 as many times as you want. And then what does Zoe say you do if you have radians? Very good. The angle plus 2 pi, the angle minus 2 pi. Very good. What do you think, people? Is that okay? That's coterminal. Then we talk about the complement and the supplement. How do I do the complement? I don't remember. Gianna, how do I do the complement? Very good. You take 90 minus your angle, or in radians, what do you do? Morgan, what do you do? If we're doing complement, we do 90 minus if we're in degrees. What do you do in radians? Very good. Pi over 2 minus. Good morning. Again. Supplement. What do you do for supplement? I don't remember, Ava. What do you do for supplement? Very good. 180 minus. Or what do you do in radians, Caitlin? Pi minus, right? Cool. It says find the point on the unit circle that corresponds to. So we've got all these. It says find point on unit circle. I don't know why I put it in quotation marks. That means you do what? What do you do? Get everything in terms of cosine and sine. Very good. Very good. X is cosine of theta and y is the sine of theta. Very good. That's a big thing you have to notice for that. Then it says to find the exact value of a trig function. So what is step 1, Caden, if I'm trying to find the exact value of a trig function? Step number 1. I don't know. Ava, step number 1. Rowan, step number 1 to find the exact value of a trig function. What did we say step 1 was when we did a bunch of times? You're thinking the right thing. What was it, Mia? No. What do you think? Yes, David. We had 3 steps. Very good. So if I hear you right, you're trying to find the reference angle. That was step 1. And then what is step 2, Caitlin? Good. And while you're doing that, remember you find out, is it plus or minus? We find the SIGN, right? And then what was step 3? Evaluate. Yes, I'm concerned for you. I hope it goes well. If you're finding the exact value, did we talk about those 3 steps? Yes? No, we didn't talk about those 3 steps? Oh, okay, cool. Okay. Word. Thank you, Avon. Okay. Well, hopefully that helps. Does that help? Yes? Yes. Step one is to just find the reference angle. It's exactly what David said. He said that, for example, let's do the tangent of 4 pi over 3. He said the first thing he notices is that pi is 3 pi over 3, right? So he would go all the way to here, but if he went all the way around, this would be 6 pi over 3, correct? So halfway in between 3 and 6 is 4.5 if you're ridiculous. So that means that 4 pi over 3 is in this quadrant. Yes? So step one is to find the reference angle. So that means my reference angle is just pi over 3. Yes? Right? And so now that my reference angle is pi over 3, what is the sign in this quadrant? Is it plus or minus? Cosine is what in this quadrant? Negative, and sine is negative, right? So that means if you ask me to do the tangent of 4 pi over 3, we're going to take the tangent of what? Oh, crap. I'm going to take the sine of 4 pi over 3 divided by the cosine of 4 pi over 3, right? Because sine over cosine. So in a minute, I know my answer is going to be a negative sine divided by a negative cosine. Is that right? So after you find the reference angle and you find out if it's positive or negative, then you can just evaluate sine and cosine of the reference angle. So I go to pi over 3, which is here in my hand, yes? Which one's on top of your hand, cosine or sine? Cosine is on top of your hand, yes? So it's 1 over 2. So cosine is on top, so it's 1 over 2. And on the bottom of your hand is sine, so it's square root of 3 over 2. Yes? And then negative divided by negative is positive. And when you take one fraction divided by another, you multiply by the reciprocal, you end up getting the square root of 3. What do you think? Yes? Cool. Again, between now and Wednesday, you may need to come in a couple times. Yes? So whatever you think you need, because we're now officially behind a little bit. If you didn't do your homework and practice this all weekend, you've had several days where you just haven't done it. So you definitely need to probably come in if you can. So before I do more of that, well, actually, no. So let's do 19. So let's look at something like 19. When it says you got the sine of theta is equal to the square root of 2 over 2, and it says find an acute angle. What does acute mean? If it's cute, it's less than 90. It's cute. It's small, right? So you have to think, where is sine square root of 2 over 2? So how do you do that? Put up your trick hand, and is sine on top or on bottom? Bottom. When would I have square root of 2 fingers? It must have been what angle? So theta must have been pi over 4. Yes? That's the acute angle that makes that happen. Yes? Then maybe the weird one is tangent of theta is square root of 3 over 3, right? Do you agree that that's the same as the tangent being 1 over the square root of 3? Yes? Do you believe that those are the same if I cancel out a root 3? That's an important distinction. Is that okay? Well, then we know that instead of cosine over sine, tangent is sine over cosine, yes? So if I put down this finger, I would have 1 square root of 1 over the square root of 3. Yes? So it's this many. It's pi over 6. Yep. So it's pi over 6. So the theta that you're looking for is pi over 6. Right? And if that doesn't make sense, you try it with pi over 6, you try it with pi over 4, you try it with pi over 3 and see which one works, because it's got to be the one of the ones on your hand. Right? So just try until you get the one that works. Find an angle. Okay. So let's look at 22 together. It says find an angle where the cosine of theta is equal to -1/2. Well, first, if it's negative 1/2, what quadrant might we be in? Either what or what? 2 or 3. Does everybody agree it's 2 or 3? Because cosine is negative here and here, right? But it must give you more information, and it does. It says we need to be between pi over 2 and pi. So we need to be between pi over 2 and pi, which means we're in this quadrant. Is that okay? So we opened up over here, and we have a cosine. No, Siri. We have a cosine of theta, which is my x-coordinate of negative 1/2. So that means if I go over here and find my reference angle, you're going to have a cosine of theta equal to what over here? Positive 1/2. Is that okay how we reasoned that? Yes? If not, can you say it a different way? Okay, so if this just has the x coordinate but it's positive now, then now I say, okay, hands, which one's cosine, top or bottom? So the top, when is it 1 over the square root of 2? It must have been putting down this finger, yes? So that means that my reference angle is actually, my theta reference is actually pi over what? 3. So now I want to come over here and have pi over 3, bless you. And so what angle would you open up to stop short pi over 3 of pi? It's 2 pi over 3. So theta must equal 2 pi over 3, because the way we're going to think about it is that if this angle is pi over 3 and this is, 3 pi over 3, because pi is just 3 pi over 3, then it must have been stopping short back here at 2 pi over 3. What do you think? Is that okay? Everybody see that reasoning? Yes? What do you think? Cool. So here's what I'd like you to do now. Take a second. Let's take 20 minutes to work on this part that we have, this first part. Then here in a minute, we will switch over to the more review for test. But right now, I'd just like you to go through ones that you think you need work on in that first part of the review, and then we will come back together. I will walk around and help you as you work on it.